What historical disasters were caused by buckling failure? Imagine a sudden, silent shift in a structure that causes everything to collapse in moments. That's what buckling failure is all about. It happens when parts of a structure bend or fold under pressure, often without warning. Throughout history, buckling has played a role in some of the most tragic structural failures. One of the most notable incidents was the collapse of a 16-story apartment building in Boston in 1971. The building was still under construction when a heavy snowstorm added extra weight. The steel beams at the top became overstressed and buckled. This initial failure set off a chain reaction, causing lower beams to buckle too. Design mistakes, like ignoring slenderness ratios and improper spacer plates, made the structure more vulnerable. This disaster shows how buckling in steel members can trigger a full building collapse. Another famous case is the Tacoma Narrows Bridge in 1940. Many think it collapsed because of twisting and fluttering caused by wind. While that was true, the bridge's design made it very flexible. The wind caused the suspension cables to twist and buckle, which contributed to the failure. This event highlighted the importance of considering buckling and aerodynamic forces when designing long-span bridges. In South Korea in 1994, the Seongsu Bridge failed after poor welding weakened the support beams. These beams likely buckled under the load, leading to the bridge's collapse. Similarly, in California in 1995, the I-5 bridge support pier failed, possibly due to buckling under the pressure of water and debris. While the Johnstown flood in 1889 was caused by the dam breaking, not buckling, it's often studied alongside structural failures. The South Fork Dam failed because of erosion and overtopping, but the failure of similar structures often involves buckling of support elements. These disasters teach us that buckling can be a hidden danger. When compression members are not designed properly, or when materials have flaws, buckling can cause sudden failure. Engineers must carefully consider slenderness ratios, load conditions, and environmental factors like wind and snow. Proper design and quality control are key to preventing such failures. From these events, we learn that paying attention to how structures handle compression is vital. Making sure beams and supports are strong enough to resist buckling can save lives and prevent costly disasters. Understanding buckling and applying good engineering practices helps keep our buildings, bridges, and dams safe and reliable.